This video consists of real numbers, part 2, and we're going to start by talking about sets and intervals. A set is a way of representing a bunch of numbers. For math, it's a bunch of numbers. It can also be a bunch of any object, like it could be a bunch of pictures or a bunch of playing cards, but it's math, so we're going to have a bunch of numbers. So a set is usually denoted by a capital letter, and the set of numbers is given between these squiggly lines that have a special name. They're called braces, like the ones on your teeth. So this would be the set of numbers 2, 4, 6, 8. We put commas between the numbers in the set. Well, there are a couple things we're going to do with sets, and we're going to find something called a union. A union, which is denoted by this symbol. It looks like a U, but it's kind of a big fat U. If you think about Venn diagrams, you probably did these in middle school. A union meant put everything together. You put both sets together. And then we had something else called an intersection. Well, like an intersection where two roads cross. But in mathematics, intersection is denoted by this big fat upside down U. So again, if I draw my Venn diagrams, the intersection is where the two sets overlap. Well, there's always the possibility that two sets don't overlap, even though you want to look for where they do. And when two sets do not overlap, we have something called the empty set. And the empty set is denoted with a circle with a line through it. In example 4 here, we're going to do a problem where we find a union and an intersection of 3 sets of numbers. Set S is 1, 2, 3, 4, 5. Set T is 4, 5, 6, 7. And set V is 6, 7, and 8. So let's start with finding the union of S and T. Union means put the sets together. Well, if I put S and T together, I have 1, 2, 3, 4, 5, 6, 7. Notice that when I put them together, I didn't write 4 twice and 5 twice. You only write it once. The intersection of S and T is just what the two sets have in common. Well, the only things that those two have in common are a 4 and a 5. And then, how about S and V? What if I want to find the intersection of S and, V? Well, S and V don't share any numbers in common, so it has no intersection. So we say the answer is the empty set. Now we're going to talk about a new notation for something that you've already seen. Interval notation is a way of writing inequalities. You're familiar with this. This is called set builder notation. It says for all values x, x is greater than 2. And if I said graph x is greater than 2, you would draw a little number line, you would put an open circle at 2, and you would draw an arrow going off to the right. Because normally the inequality arrow tells you what direction to point the arrow on your number line. The way interval notation is written is we say that we start at the number 2, and then we go to the right forever. Well, in mathematics, forever is denoted by the infinity symbol, the sideways 8. Now, there are going to be some symbols around these two. I'm going to put parentheses. In mathematics, the parentheses represent your open circle, because here's another problem. What if I gave you for all values of x, x is less than or equal to -3? And I said, graph it. Okay, so first of all, you draw your number line. You would put, this time, a closed circle at -3, and the arrow would go off to the left forever. In interval notation, we would write this as -infinity, comma, -3. Well, that's kind of weird notation. Let's talk about it. Well, the reason that negative infinity came first is because if you think about the number line, the graph is going to negative infinity in the left direction, and then it stops at -3. But instead of an open circle, we used a closed circle. The bracket here, that's like your closed circle on a number line. The only time you use a bracket in interval notation is if there's a closed circle on a number. We use a parentheses if it's an open circle. Infinity and negative infinity always have parentheses because really there's no stopping number. If there was, we would tell you what it is. Well, these weren't the only inequalities we had. We also had inequalities like this. -3 is less than or equal to x is less than 2. This was called a compound inequality. And the way it worked was you would put a closed circle on the -3, but an open circle on 2, and you would connect them. And the reason is because x is literally between those two numbers. In interval notation, we would put bracket -3, comma 2, parentheses. This is called interval notation, and this is the notation that we use when we get to calculus. So we want to start practicing using it now. Again, the bracket is used for a closed circle at a number. The parentheses is used for an open circle at a number. If the graph goes off to the right forever, the second value is infinity. If the graph goes off to the left forever, the first value is negative infinity. It just says going in the negative direction forever. Both infinity and negative infinity have parentheses rather than a bracket. So let's practice graphing real fast when you're given an interval in interval notation. So the way -1, 2 would work is you would put a closed circle at -1 because it has a bracket, an open circle at 2, and you would combine them. For the second one, 2, 3, 4, you would put a closed circle at 1.5, you would put a closed circle at 4, and you would connect them. For C, you would put an open circle at -3, and since the second part of the interval notation is infinity, that's this direction, that's positive infinity. To the left is negative infinity. In this next problem, we're going to find a union and intersection of an interval. And I want you to notice that both of these problems have the same intervals, but one of them is finding a union and one of them is finding an intersection. So I only really need to draw this graph once. So I'm going to draw this graph. One of the intervals goes from 1 to 3, and the other one goes from 2, 4, 5, 6, 7. So 1, 3 is open circle on 1, open circle on 3, connect the dots. 2, 7 is closed circle on 2, closed circle on 7, connect the dots. Part A is finding the intersection. The intersection is where the two overlap. Well, this is where they overlap. They overlap from 2 to 3, and 2 had a closed circle, so it had a bracket. 3 had an open circle, so it had a parentheses. For the union of these two graphs, remember union means put it all together. Well, that means that I start at 1 and I end at 7. Since 1 had a parentheses, 1 has a parentheses in the final answer. Since 7 had a bracket, 7 has a bracket in the final answer. The last thing that we're going to talk about is absolute value and distance. You may recall that absolute value bars are the distance away from 0 on a number line. The definition of an absolute value is that the absolute value of A is equal to A if A is greater than or equal to 0, and it's equal to negative A if A is less than 0. This definition becomes important later on, definitely for calculus. But I want to show you why. In Algebra 2, we learned about the graph of an absolute value function. And the graph of an absolute value function was a V. The general absolute value graph, y equals the absolute value of x, was the graph that went through 1, 1, 2, 2, 3, 3, 0, 0, negative 1, 1, negative 2, 2, negative 3, 3. So it's kind of like we took two lines and we connected them at the origin. So if you just think about this part of the line and ignore the fact that it's actually a v for a second, that line there is the graph of y equals x. It has a positive slope. However, this line here is the graph of y equals negative x. But it's only part of the graph. Y equals negative x is only the part where x is less than 0. And y equals positive x is the part where x is greater than or equal to 0. That's where the definition comes from. So now let's evaluate some absolute values. Absolute values are easy because the number that comes out of an absolute value bar is always positive. So the absolute value of 3 is 3 because 3 is 3 units away from 0. The absolute value of negative 3 is also 3 because negative 3 is 3 units to the left of 0. The absolute value of 0 is just 0. Now let's go to the not so pretty looking one. Now let's talk about the absolute value of 3 minus pi. Well, I'm going to look at this from a numerical standpoint for a moment. Here's the thing. Think about pi like 3.14. If you do that, then you go, okay, so 3 minus 3.14 is going to be negative 0.14, and so the answer must be 0.14. Now I'm going to look at this from a different standpoint, because the answer that comes out is not 3 minus pi. Because if the answer that came out of the bars was 3 minus pi, the answer would be negative 0.14, but it's not, it's positive 0.14. So what happens if you flip this? When I flip it, the same number comes out. So it turns out that the absolute value, let me use a different color here, the absolute value of 3 minus pi is actually pi minus 3. That's kind of interesting. Another way of looking at the problem is to say that the absolute value of 3 minus pi is going to be the opposite of 3 minus pi, because 3 minus pi gives you a negative. That's negative 3 plus pi, which is actually the same thing as pi minus 3. This is the more important of the absolute value properties. So the properties of absolute values are the absolute value of a number is always going to be greater than or equal to 0 because you always come out with a positive. The absolute value of a number is equal to the absolute value of the opposite of a number because the number that comes out of the absolute value bars is always positive. When you have two numbers being multiplied together under absolute value bars, it is the same as multiplying the absolute value of each of those numbers. And that is also true for division. If you have a fraction under an absolute value bar, it is the same as taking the absolute value of the numerator and denominator and just dividing them. The last thing that we're going to look at is distance between points on the real number line. And instead of introducing it and then doing a problem, I'm actually going to do the problem in order to introduce it. I want to find the distance between negative 8 and 2. So if you think about this on a number line, 0, here's 2, and then negative 1, 2, 3, 4, 5, 6, 7, 8. So what you can do to find the distance between the 2 points is you just kind of count the tick marks, right? It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, I counted from the wrong place. Don't count from the first one. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 spaces between them. Well, there's a definition for finding the distance between 2 points on a number line. And the definition is that the distance between points A and B is the absolute value of B minus A. Actually, it could also be the absolute value of A minus B. We're going to check that out. So what I could have done is I could have done negative 8 minus 2, which is the absolute value of negative 10, which is 10. I also could have done 2 minus negative 8, which is 10, but the absolute value of 10 is 10. So the distance between 2 points on the number line can be found by subtracting the two values and finding their absolute value.